Hello and welcome to Bloke on the Range, and today we're going to be nerding out about this really rather interesting kind of Nordic walking pole tip looking muzzle brake slash compensator, the Walker Defence Research NERO 9. Now what I thought we'd do first is have a little tour of the principles of muzzle brakes and compensators. This is on my CMMG. They call it radial delayed blowback, but it's a rotary delayed blowback, 9mm 16-inch PCC AR15 upper. Now, basically, to understand how muzzle brakes and compensators work, we need to understand how recoil works, or at least the recoil that comes directly from the cartridge. Now, once the cartridge ignites, the bullet and the powder starts to accelerate that way, which gives us a reaction force in the other direction. This increases until we get to the muzzle, and then the bullet leaves. And there's also a huge blast of gas that comes out like a rocket nozzle. And at some point, I'm going to do some serious deep dive first principles in the sort of internal ballistics of recoil. But there's this huge myth that recoil doesn't happen until the bullet has left the muzzle. Whole topic in and of itself, but Newton says no. And so if you just look at high-speed footage as well, you see it's not true. Anyway, so what can we do to mitigate the recoil that is due to the cartridge? And I'm distinguishing this from the recoil due to what happens at this end with the working parts moving and bashing into things. Also a topic that will come up again in a bit. So literally we can't really play on the bullet. The bullet's going to be going off at whatever velocity it's going to be going off at. I mean, we can shorten the barrel to reduce the velocity, but do we really want to do that? Probably not. We tend to want the velocity to be higher. But we can manipulate the gases. We can change the direction of the gases that are coming out to make them do work to compensate what they were going to do anyway. Now, the traditional way of doing this, let's just take this one, is that you put a muzzle device on there, and that has a series of baffles, surfaces, against which the gas acts. So this is an Oberland Arms one. There's a hole for the bullet to leave, and the closer that hole size is to the bullet diameter, the more efficiency you can get out of the brake. There's some baffle surfaces here. These ones are slightly angled forward so that it's less nasty for the user and the bystanders. The gas expands out of the muzzle, impinges on these surfaces, pushes the brake forwards. Now this one, before I had it machined to make it a little asymmetrical, was symmetrical. This is a pure 100% muzzle brake, as in it only supplied axial resistance force. It pushed forwards along the bore axis. You make it asymmetric, and it will compensate. That is to say, it'll counteract the muzzle flip, which is the muzzle coming up like that as the firearm rotates upwards on firing due to the geometry of how it interacts with your body largely. Now, most muzzle brakes will compensate a bit, and most compensators muzzle brake a bit, at least a bit. Here's an extreme one made by an acquaintance in Finland. This was intended to be a PCC for this, but I never put it on because the owl's a little bit scarily small. I wasn't convinced that was going to line up well enough. So here, this is almost a very compy comp. Basically, nothing can come out the bottom. It all comes out the top, and then we've got two massive baffles here. So the gas pushes against the baffles and exits out the top, pushing down. We've got some examples of, well, another one here. This is a Navratil N2 for an AK. This is quite upwards biased, quite aggressive, very, very effective brake. At the other end of the scale, we've got, these are practically a pure compensator. So if I zoom in here, this is an AKM slant, sometimes called a slant brake or a compensator. I'm not too hung up on terminology. There is a little bit of a baffle here, so this will have a little tiny bit, probably imperceptible, probably immeasurable, bit of muzzle brake. But what this does is it sits on the rifle about that angle. And it's basically a spoon that just gets pushed down by the muzzle blast. So muzzle blast has a tendency to go that way. The gas that would have gone that way ends up going not that way, mostly up, and that pushes the barrel down and slightly to the left to compensate the tendency to go up and right. Another example, here's a M16A2 type flash suppressor. Again, we've got a little bit of baffle, not a lot, but because it's closed on the bottom, it does have a tendency, and it is measurable, to counteract muzzle rise, which is a good thing, and also it stops it kicking up dust. I think the most primitive pure compensator I can think of, and obviously I don't have one, is the very, very plain press steel spoon compensator on a Sten Mark 1, so I'll put a picture of that up. So that's the basic theory of muzzle brakes / compensators. This one totally breaks the mold. Now, most of these designs, they're just arrived at empirically by someone thinks it's a good idea, let's test it, does it work, does it not work, shall we drill some holes on the top, shall we change the angles here? And as a general rule, the more effective a brake is, the nastier it is to the user. I mean, here, this Oberland one, they've made an effort to make the baffles a bit forward biased, so you reduce its efficiency, but you're not directing as much gas back. The Navratil has a backwards rake. These are deeply unpleasant, but very, very effective. This is based from scratch. This was designed from the ground up, and I had a very interesting conversation quite a while back now with Drew Walker of Walker Defence Research, and I'll explain in a minute what's going on here. But first, a quick point on PCCs, so pistol caliber carbines, versus proper rifles. The issue with the PCC, 223 Remington, 9mm power, two absolutely standard cartridges. The power factor of these, out of a 16-inch barrel, so the momentum is about 150, momentum of the projectile. So in principle, the recoil due to the bullet's velocity is about the same. However, there's two major differences. You've got 4 to 5 times as much powder in here, and it's leaving at significantly higher pressure. I mean, 9mm power was designed for sort of 4, 5, 6-inch pistol barrels. It optimizes out velocity-wise somewhere around this range, possibly a bit less. You need to look at ballistics by the inch. But the muzzle pressure from 9mm is quite low, and you notice this when you're shooting because they're not unpleasant to bystanders. They sort of go tick, tick, tick rather than boom, boom, boom. So what this means is you've got a lot less gas to play with in the first place, like 4 to 5 times less, and it's at a much lower pressure. The other issue is that in the case of the standard blowback 9mm AR15 uppers, and this is another interesting thing that we need to get into, is the recoil in non-locked systems, because that's fascinating. But in an unlocked system, the vast majority of the recoil actually comes simply from the bolt carrier group smacking the buffer at the back. And it's very interesting to watch, and it's not a topic for today. But anyway, the recoil profile, the felt recoil profile, is quite different in a PCC than in a 223 because of that, and they tend to jump quite a lot. The recoil is much more jumpy and less pushy backy, and you would expect actually that just because it's a smaller cartridge, you'd expect the recoil to feel less, but it really doesn't because of that. And even with this system, with the craptastic brake that came on this, it was, yeah, miserable. I'll insert some earlier footage of how much that moved around. Now, with PCC brakes, there's a bit of a tendency to simply take a 223 brake and bore it through, or to scale another design, a design that was worked out for 223, and then scale it in some way. This brake, I mean, if it had an exit port like that, I mean, these do actually work very well in 223 with the 223 exit port. The problem is that with 9mm, you've got the muzzles right back here. You've got this kind of big expansion chamber that just opens out into a whole bunch of nothingness. You've got some bleed holes on top, and you see a bit of gas comes out of them, but you've reduced the pressure quite a lot already. And then these baffles are forward biased anyway, and they're tiny. There's almost nothing there. So I'm not sure this does a lot. Not measured it, not fired it without it on, but this did not seem to do very much at all. So, Matt in North Texas actually sent me a 223 NERO brake, and what the NERO 9 did is it's a different design. It's the same principle. They're more or less the same, if not exactly the same, outside dimensions, but it's a redesign on the same principles, and you can see that the outlet ports are quite different. And I've not had the chance to put this 223 one on a rifle yet, so I'm going to talk about the 9mm. Now, this shape cannot be made by traditional machining. About the best you could do would be to make it in 2 halves and weld it together with all the structural issues that that come with that. Now, it's actually 3D printed from Inconel, which is an aerospace sort of superalloy that can be selectively sintered by laser, effectively. And this means that you can make all sorts of interesting internal shapes that you can't machine normally. Now, let's just zoom in there. And what's interesting about this one, just from an aesthetic perspective, and this is something that Drew pointed out, was as you turn it, the ports seem to sort of look at you. And you might notice in there, and I've got some footage from before we fitted it, of the inside. We've got the sort of golf ball texture on the bottom face, and we've got a curved face there. And what you can't see here, so I'll insert some footage, is you've actually got a slight ramp in the top there. So what we've effectively got is one large internal baffle, and we're trying to do a lot of the work inside the comp. So that slanted surface in there, which if Drew hadn't told me about it, I wouldn't have spotted it. And this one's been fired, so you can't see. The advantage of what we filmed when we fitted it is it was pristine, whereas now it's not. So we direct it down a bit, which actually in principle works in the wrong direction, but it's so mild. And we're trying to get the 2 internal surfaces, so the golf bally surface and the end surface, to do most of the work. Now, the purpose of the dimples there is to increase the surface area and to generate turbulent flow, sort of like a golf ball. And in a golf ball's case, it's all about separating the boundary layer and making it fly further. But here we're trying to make it swirl, make the gas do work internally. And then we let it out through a series of very, very small ports that have been calculated with precise angles, and they are quite different from the 223. And you see there's a lot less upwards bias on the 223. This is very much intended for the PCC muzzle flip issue. Now, how do you arrive at things like this? And the answer is that it was not empirically designed. It was designed from the ground up. There's been 2 US patents granted to the principles involved in this brake, and it was designed with fluid dynamics and intended to be kind of the best best brake possible. And it's always a compromise, because as I said before, you can be very effective and very nasty. You can be less effective and less nasty. And that was taken into account with the 223 one. And one of my shooting friends has a sort of very, very, very upwards biased, conventional, empirically designed comp that shakes dust down from indoor range ceilings. This is actually pretty pleasant, pretty quiet. So anyway, basically fluid dynamic modeling and iterating the design to try and come up with a way to maximize the work that the gas does without overcompensating it, because overcompensation is real. You don't want the rifle to kick down any more than you want it to kick up. Ideally, you want it to be as stable as you can, and that's always a bit of a compromise, and it's always a bit ammunition dependent. So I think this is a fascinating bit of design. Of course, there are cheaper 3D printable metals that could have been used for the PCC, for the 9, but Drew's position on it was basically, we can do it, so why not? We're set up to do Inconel for 223, so let's just spare no expense. And actually, compared to other top-end brakes on the market, they're not incredibly expensive. And this one, they are back in stock. I have held off on this until they were back in stock, so you can go order them. Now, quite a while prior to filming this, I took it to the 50-meter range and had my first impressions, and after that I took it to a comp where I couldn't film, and so let's have a look at my first impressions on the range, on the static range, and then afterwards I'll talk to you about how it went in the comp. Okay, so I've not shot this yet. This is my first impression. I can't shoot fast at this range, but doesn't really matter. So I'm going to kind of take my usual grip. Wow, that was amazing. This is 115 grain gecko, Hungarian gecko, the white box, and that hardly kicked at all. In fact, it kicked slightly low and right, and then came right back on. That one was slightly high and right and came right back on. So let's do the absolute test. Okay, that was more, but with a modern, nice grip out there. Woohoo! I'm shooting at 50 meters here, and it's not moving more than about that much, sort of up or down a bit. 3, 2, 1, you're back in the room. So first impressions on the static range, as you can see, were kind of positive. However, when you're shooting at 50 meters against like precision targets, you see like everything. And the real question is, how does it perform on the clock? Now, as I said, I wasn't allowed to film at this match, but I shot it. I was very happy to win it, and it really does exactly what it says on the tin. It very much passes the Ronseal test. And we're shooting it with my what was Stoner Do Lower, which has the very nice SLT1 trigger from KE Arms in it, and the sort of PCC competition distances on PCC targets. So it's basically like IPSC pistol type disciplines on similar targets, big targets. It's fast. It's mind-blowingly fast as a discipline. And what I found was I could put the dot from my Holosun 503 on the target and then practically slap the trigger twice. And there was just almost no movement. I mean, at sort of 10 meters, I just come up, trigger it twice, and the shots would be right next to each other. So I was literally not having to think about where the second shot was going to go. I knew that with the sort of modern reach out thumb over grip with my slate stop from Slate Pack Industries, from Henry and Josh over at 9 Hole Reviews, that I just had to get the dot where I needed it, and this trigger's good enough, even at 4.5 pounds. It's so crisp, I could very quickly trigger 2 or 3 shots, and it would just stay put. Just like lock it in, first one's on, second one's right next to it. There was one particular target presentation where we had a dropping shutter, where you stamped on an actuator cord or knocked it with your leg, and then the shutter opened and the shutter closed, and it was very, very, very quick. And what you did with that one was you lined up where you knew it was going to be, you actuated, and then you just went. I ended up just triggering it 3 times because I could see it was still open through the dot. It wasn't noisy. It really is very very good. I think it's a very good match with this delayed blowback upper, even though it's intended to work with conventional straight blowback. I'm really impressed with it. Drew at Walker Defence Research, you have done a thing and it is good. I'm impressed. I'm looking forward to testing the 223 one on probably my What Would Stoner Do. Yeah, basically this is awesome. If you can afford it, buy it. What else can I say? So anyway, thank you all so much for watching. Thanks so much to Drew for his patience in waiting for me to actually have the time and capacity to produce this video. Thank you so much to patrons who keep the channel chugging along and allow us to do all sorts of fun stuff. So if you would like to consider being a patron, or if you don't like Patreon as a principle, we're also there on Utreon, all donations gladly received. Thank you so much. If not, please just like and subscribe and share the videos, and onwards and upwards. So see you again sometime. Bye.